let me pick on somebody. Anthony, how did you label your rectangle sides? Where was your X? On the width or the length? The length. This guy? Alright, so what's your formula for perimeter? 2x plus 2y equals? Is this exactly like number 5? Right? So the only thing that changed is the perimeter. You guys should be able to plug this one right into the same formulas. Alright, so area. You're maximizing your area. Back to this problem. You're maximizing your area. Oh my goodness. Alright, let's go back up to this problem. You're maximizing your area of your rectangle. We did the same thing with number 5. And I wanted you to do the same type of setup here. So what goes in your y1? In your calculator? What's the formula for area of your rectangle? xy. Now, what's the problem with that y? Yeah, you got to substitute it out. So you're going to solve this y in terms of x. So subtract your 2x from both sides, divide by 2, and substitute that into here. At this point, you guys should be able to do this substitution. It's just when you have one equation, you can only have one variable. 2 equations, 2 variables. You did your systems of equations, and you did the addition method, and you did the substitution method. This is just a substitution method. So we're substituting one into the other. So once you put this in, you graph it, and you should see a parabola that opens up here and get its maximum point. You're maximizing your area. You want the largest area possible. And what was your turning point for this? Everybody get a turning point? Paul, get a turning point? 981. Good. Now, remember, that's the x value. This is your maximum area, not your other part of your rectangle. So one of 2 choices. Since your area, you could divide 81 by 9, or come back over here, plug your 9 in here. And y is also equal to 9. So the answer I want back is your rectangle, x is 9, y is 9. Your maximum area is 81. Okay, you maximized your area with a perimeter of 36. Remember, you can have different measurements, but that will give you your maximum area. And your perimeter is probably set at the smallest. Now, let's verify this algebraically. Let's just go through this algebraically. This kind of ties it all together. Take your formula. Take your formula and put it over here, and let's complete the square. Right, let's go through and complete the square. See if we come out with the same vertex that you did using your calculator. So let's distribute. And let's turn this around. Now, we need a third term to complete your square, right? This is what we were working on, complete the square. If I add something to this guy, I also have to subtract the same thing. Now, my problem is A has to be 1, positive 1. I got to get this negative back here. So I factor out the negative 1. That becomes a positive. That becomes a negative. This guy's going to stay positive because whatever we square is always positive. What does this negative 1 do to my parabola? down. And don't we have one to maximize? So it's half of negative 18. Negative 9. What's negative 9 squared? 81. If I add 81, I have to subtract its equivalent, but I gotta get it out of this parentheses first. So I say, okay, a negative 81, I subtract a negative 81, which causes me to add. Bring down your negative, and there's your same equation in vertex form. So here's your vertex, your turning point, 9, 81. Isn't that what we found? Here's your 981. Here's your vertex form. Now, we completed this square before, and all we did this time around was graph them, so that you actually can just find them on your calculator. God bless you. Questions on this? Can everybody do this? Tell me where you have any problems not doing this. I don't see everybody's sheets completed. This one should have been easy because it modeled the problem that we did yesterday. Yes. You have your homework? Okay. All right. Number 7. I had you do number 7. Okay. Find the length and the width of a rectangle that has an area of 64 feet and a minimum, here's your minimum, this is going into your Y1. Here's your rectangle. And you can label your rectangle X, Y, wherever it is you want to label it. And substitute it out. Even if you say the width is X and somebody else says the width is Y, you're still going to get the same two numbers. It's still going to be a rectangle. So label XX, YY. Your area, they gave you this piece of information. Your area is 64. And your perimeter says 2X plus 2Y. I factored out a 2 in mine. You don't have to do that. You can leave the 2X plus 2Y. You're going to substitute out your Y, 64 over X. Okay, you can just substitute out your Y, you can leave it that way. Either way is fine. There are two. Well, your standard formula is this, right? I just factored out the 2 in mine. So that's the same as saying 2X. Oops, that's what you meant, 2. Yeah, that was the 2. Yeah. So you take the Y out and I took the 2 out. Okay. So either way is going to give you your minimum. Now, your minimums, I think they're easier to find on your calculator because part of the problem is how high do I set my maximum. And this wasn't very big numbers to look at. You can scan through your table. Can everybody do that and set their window? Anybody have a hard time setting the window? No? Okay. So everybody found this minimum point? So what does the 8 represent? X, which is the width. I should have set my TS statements. Make sure you give me a let statement. X is your width. What's 32 represent? Not Y, not area. What you put in your Y1? Perimeter. This is your perimeter. Substitute this guy back into here and find your Y value. Now we've been seeing if you're minimizing, maximizing, or minimizing your perimeter, you're probably looking at a square, which makes sense. Questions? Okay. Alright, I didn't give you this one, but I would like to try this one with you. The only problem was your calculator. So let's put this in your calculator. Everything was pretty much there. The calculator was, God bless you. This is a flow rate, God bless you. And a rate is a percent. But a rate in an equation, a percent is moved to a decimal. So your rate is very small. So everybody pull up your calculator and let's put this in your calc. Just like you read it. If you need to use your fraction key, that's fine. God bless you. And use your X instead of a V. You can use your fraction key or just use parentheses in your denominator. Now this says on any given day the flow rate, F, is cars per hour on a congested roadway, and they give this, where V is the speed of traffic in miles per hour. That's your X. X is your speed, your miles per hour. What speed will maximize the flow rate? Maximize means which way is it going to turn? Down. Turning down. So get the highest point here. And turning down, there's your X squared part. We've got a little bit of a domain restriction, but we'll see what happens. So I'm going to zoom 6 to start. And again, we only want quadrant 1. So let's start with quadrant 1. This is a really good exercise in playing with your calculator. Now, here's my quadrant 1. I'm still really barely seeing this. Look where your table is. Set your table at 0, and look where your y's are. Now look how small your y's go. Your y is a decimal. It's a rate. So your rate, like 30%, is 0.3. 80% is 0.8. Your rate is small. So what do you suggest you change in our window? Your y. So what should we make our y? Our y min has to be 0. What should we make our y max? 5 would put me at, if it was 5.0, it would be 500%. 1, so let's go with 1, because 1 is your 100%, right? So your rate should go from 0 to 100%. Unless it's over 100, but probably not. And let's see what we graph. We're getting there. What do we have to change? Because I really don't see any curves in here. X. You're going to have to change your X. So your X represents the speed of traffic. Right now, our window, our X max is 10. Our maximum speed is 10. What would you say on an average day the speed is on a road? 40? Right, let's go with 40. That's what I'm saying, guys. A lot of this is common sense. You just have to think it out. I'm getting there. I can probably see a turn, but maybe make X a little bit larger so that I can get it all the way back down. So, rule of thumb, just go double it. Don't play with it, just double it. And now, do we see it curve down? Can you do a maximum and find me your rate now? Remember, your rate is going to be a decimal. Because really, if we move the decimal 2 places, it will be a percent. So do a maximum and find your rate. This was not a bad one. The only thing you had to really make sense of was the rate part of it. So I didn't want you to have to do this at home and to panic because you couldn't get it to come out on your screen. But it's a really nice basic one. We have the maximum. Everybody find the maximum? Other than me. You got this? Remember, 3 decimal places. So this is what you're doing. F is your flow rate. This is your rate, your flow rate. So it's about 75%. This is your X. This is your speed. There's nothing else to substitute in here because your X represented your speed, or your V in this case, and your F represented your flow rate. So your rate, again, is small because if I move the decimal, it's about 75%, which kind of makes sense. Your traffic should be flowing, right? At a good clip. It shouldn't be at 30%. Nobody would be moving hardly. Okay? And that took care of that one. So let's take a look at number 5. Number 5, guys, is like an algebra 2 problem. This is like an algebra 2 problem. Throwing a ball, launching a rocket. Your ball has to go up in the air and come back down. Towards the end of this course, you do parametrics. Anybody here take physics? Anybody in physics? When we do parametrics, this is really cool. You probably do a lot of this in physics, but when we do parametrics, we actually can measure 3 things. Right now, you can only measure 2. Right now, you can measure time usually, and height is usually what we measure. This is usually time, this is usually height. Sometimes this is your vertical height, sometimes this is your horizontal distance. This is horizontal distance. When we do parametrics, we'll be able to do your horizontal distance, your vertical height, and when we watch the parabola go through, this will actually represent our time. So you guys in physics may hit that before us, but that's what we'll get to probably like 3rd or 4th quarter. We'll hit parametrics. And that's a nice like physics thing to throw in there. Right now you can only measure 2 things, an X and a Y. So they have the height of a ball as your Y, and they measure the horizontal distance. So this is the height, vertical, this is the horizontal distance. Okay, and you can see the ball being thrown. How high is the ball when it leaves the child's hands? She's not sitting on the ground. It came from up here and then falls down like this, if you put this on an axis. And that makes sense, right? If you're standing here, do you roll it? You throw it. So your arm is up here, and you let it go. You have this distance here. How high off the ground is she using that equation? I hear 4 and 6. 4 feet. What is X at this point? X is, this is your axis. What is the value of X right here? 0. So here's your Y-intercept. 0, 0, 4 feet off the ground. She's standing 4 feet off the ground when she goes to throw the ball. Makes sense. A little kid is about 3 or 4 feet high, right? Makes sense. How high is the ball at the maximum height? Okay, we need to either graph this, they gave you the equation, or you can complete the square. So why don't we complete the square? Let us complete the square, and then we can see how far it strikes the ground as well. So let's complete the square on this guy. This is good practice. We're going to leave the 4 out here, then subtract something. What do we have to do to start this? Take out the negative 1/2. Now, remember, if you took out a 2, you divided everybody by 2. If you take out a half, you divide everybody by a half. This causes 2 divided by a half. Keep, change, flip it over. That becomes 4, and it becomes a negative 4. Alright? What's half of negative 4? Negative 2. What's 2 squared?
4.
Now, it's sitting in here in this parentheses. It has to come out. So we have to, because this is not really x squared. This is negative half x squared. So distribute that. So that becomes a negative 2. So a negative of a negative is what? A positive. Bring down this negative 1/2. That's going to make your parabola turn, and it's also going to widen your parabola. And isn't that what happens? When you throw, it probably doesn't go straight up and come down like this. It probably goes a little bit wider, doesn't it? It makes sense. So, what's your turning point up here? What's your maximum point? 6, 2, 6. Good. So your maximum height is 6. It's 2 feet from the ground, 2 feet from where she's standing, and your maximum height is 6. Now, when it hits the ground, how do we find out when it hits the ground? I'm using the zeros. Good. Because y is 0 over here. So take this equation and put y of 0 in here. So we're going to subtract 6. And divide by a negative 1/2. So if we divide both sides by a negative 1/2, what do we get? 12. Good. And then we take the square root. Right? Okay, so the square root of 12 plus or minus. And then we add 2. And reduce this out. Radical 4 times radical 3, so 2 plus or minus 2 radical 3. Now if you do it on your calculator, you're not going to see a radical, you're going to get the decimal value. Which one do we want? Do we want the positive one, or do we want the negative one? Positive, because we want it ahead of her. So when it hits the ground, it will be 2 plus 2 radical 3. And you can do this whole thing in your calculator as well. Do the whole thing in your calculator. And how do I find how it hits the ground? In my calculator. Don't do trace. Second trace, and what are you going to look for? Zeros. Good. Very good. So let's put this guy in. I'm just going to do a zoom 6 to start. And again, we're in quadrant 1 only, which, look, this makes sense, doesn't it? It's a parabola, so it existed somewhere else before this. So we're cutting off to quadrant 1, so all we have to do is change your x min to 0 and your y min to 0. You could have done this whole thing graphing. This was really nice on your calculator. Do your max to find your turning point, 2, 6. Come down here, like Rich said, do your zeros. It's a 0 when it hits that. So come down here and find your 0. You have to stay to the left. Then you have to go to the right. Just watch where you're going with your y. Watch y. When y is in the negatives, it went past. And that's where it hits the ground. Now if you take our 2 plus 2 radical 3, it comes out to 5.464. Your calculator is not going to return a radical, of course, but you can get your radical when you do it algebraically. So does this make sense? Yeah? Don't get too excited about applications. All right, let's try one more. Go to number 2 in that packet. We'll use complete the square as well, so we'll fill the squares with what's going there.
It's off the mic. There it goes. Alright. So let's take a look at number 2. Start reading number 2, guys.
A rectangular area is to be fenced against an existing wall. So here's my wall. Here's my rectangular area. Which one is this very similar to? The one with the river. The river? Yeah. So a rectangular area is to be fenced against an existing wall. 3 sides of the fence must total. Here's our piece of information. Here's your perimeter. So perimeter is find the dimensions of the maximum area. That's what goes into your Y1. Okay. And you want to know what your maximum area is. So let's label, and let's put our let statements this time. And it doesn't matter which one you label X or Y, your dimensions will come out the exact same. Just reverse. So how do I set my perimeter up for this? Good. And how do I set my area up? That's what. Your rectangle area is always the same, length times width. So we're going to substitute out the y in our y1 equation because we only can use it in terms of x. So we're going to come down here and we're going to subtract 2x from both sides. And we're going to substitute it in here. Now, here's another trick to find your domain, to find where your x's are. This is a parabola. Which way is it opening? Just distribute the x. Down. It's going to open down because we want to maximize, right? We want it to open down. When it hits the x-axis, our y is 0, right? So doesn't that give me my x that I need from here to here? So if I set this equal to 0, I should be able to find my domain for x. So x is going to go from 0. This is where it hits the ground. Subtract at 2x. Divide by 2. So my x should go from 0 to 525. Does that make sense? You've got a parabola. It's going to come out here, and it's going to go like this, right? From that x to that x. Isn't that my window right there? My domain for x? Isn't this where my 0 is for my y? These all kind of connect to the dots here. So let's put this in your calculator, and let's give this a shot that we can make your x go from 0 to, say, 600. And your y is going to have to, your perimeter is 1050, and your area is multiplying. So which one's going to be larger, area or perimeter? Perimeter. Now, here's another easy way. Watch. You're after this. Watch your calculator. Let me put your equation in. Left. All right. I'm going to graph this. Now, we said that your x is going to be from 0 to 525. So let's just go set your x from 0 to 525. So we'll make it 550. Just so we see the bottom. Let's count the 550. 225. So let's look at your table. Table set. So we'll just estimate. It doesn't really matter. 275. So we'll start at 275. Because I know I'm close enough, even if we went with 225. Look how high your y is. So we could do ours at 200,000. This is a good way to figure out your window. Another way to figure out your window. So set this to 200,000. It's probably way more than we need, but all we really care about is if this changes. Your scale just tells you like how dark those lines are going to be. Those lines are going to be really, really dark if you scale by 1. So can you now find your turning point? That was another nice way to find your window. Find your domain. Look up that point that's halfway. Look where that y is. So instead of scrolling through my table up to the 500s or the 200s, I can easily just pinpoint that turning point. Okay? So everybody's good for a little test tomorrow?
What?